All right, so continuing where we left off in part one, the next thing I did was I just zoomed out and I looked for places where your gyro traces went big, because I figured that's a big maneuver that you're doing. And I saw this one, which is yaw. And one thing to keep in mind is that the traces in Blackbox, they're non-linear. So the fact that yaw is sort of peaked up at the top here, but notice that the stick is barely deflected, whereas this move here is like a full flip. And the fact that both of those lines are kind of the same height in Blackbox, don't let that fool you. It's a exponential curve, so when you get to the top, it sort of flattens off, and down at the bottom, it's got a lot more sensitivity. But I did find something interesting in here, and this is what motivated me to keep going with your analysis and instead of just cutting it off. So let's take a look at this move. And what I want to do is I want to have, let's have RC command yaw and RC command roll. And let's have gyro. How do I want to do it? Let's have gyro roll. RC command yaw. Let's do it this way. Gyro yaw. Let's put yaw up on top and RC command roll and RC and gyro roll on the bottom. Okay, you got that? Oh, I need to fix that though. RC command roll. I clicked the wrong one. Okay. So now I'm going to play this move for you. It's just sort of a sloping turn. Nothing dramatic there, right? But did you see what I saw? What happened at the end of the turn? Let's watch it again, and I'll slow it down. Right there. It pitched to the right. It pitched out of the turn. And I noticed that immediately and asked myself, first of all, did you do that with your sticks or did that happen in spite of your sticks? So let's take a look at the traces. Here is yaw, okay? So when RC command comes back to 0 here, you've commanded the end of the yaw move. And by the way, notice that the yaw move, it doesn't end terribly abruptly, but there's nothing to complain about there really. Let's see, 3.705. And the yaw move actually ends, the gyro is at 0 at 3.841. So it took about a tenth of a second from the moment you centered the stick to the moment that the copter stopped moving. Nothing really to complain about there. It's a tenth of a second, that's fine. Maybe it could be a little faster, maybe, but that's a sort of a bigger tuning question. But then notice also here is where the copter starts to roll to the right. And the question is, why is that? And it's a little confusing, actually, because, let's see here. So here, if we look at the gyro traces, now one thing that's a little confusing is that roll and yaw are actually opposite sign from each other. So left yaw is positive and left roll is negative. So when yaw and roll are on the opposite side of the axis, they're actually coordinated. So that's a little counterintuitive, but just get used to it. So you've got this coordinated turn here where yaw and roll are on opposite sides of the line. And now this is where roll changes sign. Now notice that roll, you end the move on roll. Here is where RC command goes to 0 and you have ended the roll move, but you are continuing the yaw move here. And here is the point where your roll gyro goes positive, and that is where the copter is, instead of rolling left, now it's rolling right again. Let's watch that slowly and see if we can. I'm going to go really slowly and just see if we can put that into some perspective. So there it's rolling right, and that's just the leveling out. You're just sort of leveling out there. But it is strange that you're leveling out because you can see that RC command is not commanding right roll. So why is it that at the moment that your stick is centered here, the copter is rolling to the right? You're not commanding that. That's a very interesting either mechanical or tuning issue. I don't that I would want to solve. I bet that you're noticing that when you fly. Let's watch it again. Here you leveled out, but you didn't command the copter to level out. It just did it on its own. And actually, I didn't even notice that when I first saw this move because leveling out at the end of the turn feels like such an intuitive thing to do that I assumed you had done it on purpose. But we can see here that RC command roll is centered. You did not command that. And now the copter levels out, and what does it do next? It actually keeps kind of going. And now you are beginning to command the left roll to fix the rolling to the right that wasn't commanded. Now you can see the RC command is negative. You are pushing the copter to the left now, and it goes back the way it was meant to be. So this here is a problem that we need to figure out how to solve. This right roll that was not commanded. Let's take a little deeper look and see what we can come up with. All right, so now I've moved the graph around a little bit. I've put your RC command and your gyro on top. It's the same graph we were looking at on bottom. It's just moved up to the top. And now I've got your PIDs on the bottom, and I've got your PID sum as this purple line, okay? And what I want to do is I want to look at the moment where the copter starts having the undesired behavior, which is the right roll signified by the gyro trace going positive. And that's right about here is where that happens. And I want to see what the PID algorithm is doing. Now, if the copter is rolling right and the PID algorithm is pushing it to roll right, then we're going to see that the PID, because right roll is positive, then we're going to see the PID algorithm pushing to the right as well. And in fact, what do we see at the moment that that move starts? Notice here is where you are rolling to the right. The gyro is positive. That is uncommanded. And notice that at the moment that that's happening, P is negative. So the PID algorithm is correct in that it is fighting that. P is opposing that move. But notice that your PID and D is not really doing anything. Your yaw D was just low enough that it's not really doing anything, so we'll just sort of ignore that. Notice that the PID sum is basically 0 at this moment in time, the purple line. Why is it 0? P is doing the right thing and is fighting the move. I is positive and is saying, no, no. So they're having a tug of war. P is saying, stop rolling to the right. And I is saying, no, no, keep rolling to the right. And the result is nothing. The yaw, or the roll PID here, is not doing anything. It's just letting the copter keep doing what it wants until the moment where you push the stick here and create more error and fix it. Okay, so we've got a situation. So how did the copter end up rolling right in the first place? Well, let's have a look here. Here the move begins. You are rolling left. The gyro is negative. And notice that for the most part, the P and I are also negative. P is pretty close to 0. When P is 0, that means the copter is doing what it's being commanded to do. And I is negative, and that is I correcting for some bias, some consistent force that is pushing on the copter, probably aerodynamic force. That's all normal. As you get into the move more, P goes positive. Notice that P is positive, but the gyro is negative. P is opposing the move now. P is saying, don't turn so fast. Don't roll so fast. So aerodynamic force or what have you is causing the copter to roll into the move faster than is being commanded, and P is now trying to slow it down. And notice that as that happens, I also goes positive. So I is in agreement now. Slow down, you know. As we can get this far into the move, notice that now P is 0. It's close to the 0 axis. P says the copter is moving as fast as it needs to be moving. Everything is right again. Why did P change its mind about the scenario? Well, potentially something external changed. But really, I think what happened is that as I got more and more positive, I picked up some of the slack for whatever was causing the copter to turn too fast, and P was able to settle down, and I was sort of carrying the weight. So now P is close to 0, and the copter is doing what it needs to be doing. As we continue into the move, notice that both P and I go positive again. Now they're both in agreement that the copter is moving too fast, rolling too fast into the move, until the moment when you get to 0 here. Now P is quickly able to respond to the stick movement because P acts in the moment quickly, whereas I moves slower and is the big I is the big picture. P is the right now. Okay? So when the stick centers, P immediately says, okay, stop. And I takes a minute to get there. And the reason that the copter rolls the other direction is because throughout most of that move, you were rolling left, but both P and I were saying, don't roll left so fast. So they're kind of holding it back. And then all of a sudden, imagine two guys are pressing on a big heavy boulder trying to keep it from rolling down a hill. And then suddenly one of them, steps out of the way. Boom, the boulder's going to roll down the hill. The system was in equilibrium, but as soon as the P term changed its mind all of a sudden, the I term was just sitting there and the copter got away from it. And so what can we change in our tuning to affect this? I think what we're seeing here is that the I gain is too high. Okay, because the I term had to carry too much, it got too large and it was over influential. And because the I term is not ultra responsive, that's not its job to be responsive. It's the big picture guy, right? Because it's not ultra responsive, when the situation changed quickly and the stick recentered, the I term was still sort of playing out a script from a half a second ago and made the copter do something unwanted. So now let's take a look at what your actual roll I gain is, and it's 52. And I'm not surprised. In fact, I'm kind of glad because 52 feels way too high for roll. I usually see roll I gain in the range of about 25 to 35, maybe 40. And pitch is often higher because of the weight distribution on these copters. We won't go into more about that, but pitch is often in the range of 40 to 60. If you didn't already have such a high I gain on roll, I would also suggest raising P. There's an interaction between P and I where if P is stronger, I has less to do. And that makes the copter as a whole more responsive. You want I doing the least amount of work as possible because I is slow to respond to changing conditions. You don't want it sort of holding the whole system back. You just want it providing the minimum amount of stability that is necessary. So if you have a situation where you have a really low P gain, there's going to be tons of error, and the I term is going to have to pick it up, but the I term is so non-responsive, the copter won't fly well. So if you've got a scenario where the I term is over-influential, the two things you can do are you can raise the P term and leave the I term alone, or you can lower the I term, the I gain. In this case, I've said in the previous video that you might consider raising your P gains and so you probably should do that first, is raise your P gains, see if that gets you a little bit more of a locked-in feel, and see if it doesn't cause any more oscillations. If it does cause oscillations, put them back where they are. But then I also certainly think roll I needs to come down, even if you raise roll P, but maybe not quite as much if you raise roll P. Okay. Well, I found that really interesting. I really enjoyed talking through that, and I hope people who are watching this find it interesting as well. That's all, and happy flying.